3I/ATLAS is doing something that should be physically impossible, and what scientists are observing is forcing them to rewrite their understanding of how objects interact with the solar wind. Solar observatories detected something extraordinary. The constant stream of charged particles flowing from the sun, the solar wind that affects everything in our solar system, is bending around Atlas. Not just deflecting slightly like it does around planets and comets, but curving in ways that require forces orders of magnitude stronger than ATLAS's size and mass should be able to generate. The solar wind flows at roughly 1 million miles per hour. It takes enormous magnetic fields like Earth's magnetosphere to significantly affect it. Yet Atlas, an object less than a kilometer across, is creating disturbances in the solar wind visible across millions of miles of space. The deflection zone extends 50 times farther than it should based on Atlas's physical dimensions. But here's what has physicists completely baffled. The bending isn't consistent. Sometimes the solar wind curves around Atlas in one direction, sometimes another. Sometimes it accelerates as it passes ATLAS, sometimes it slows down. The patterns change in ways that suggest active manipulation rather than passive deflection by a magnetic field. Before we break down what's causing this impossible phenomenon and why it suggests ATLAS has capabilities we never imagined, hit that subscribe button and smash the like. Because what you're about to learn reveals Atlas is manipulating fundamental forces in ways that challenge our understanding of physics itself. The solar wind has been flowing through our solar system for billions of years, following predictable patterns, until ATLAS arrived. Now those patterns are breaking down in ways that suggest we're witnessing technology so advanced it can reshape the space environment around itself. Here's what makes this so absolutely insane. The solar wind is one of the most powerful forces in our solar system, and nothing small should be able to mess with it. But ATLAS? It's treating the solar wind like a toy. Imagine a river flowing at hundreds of miles per hour. Not water, but a plasma river of charged particles shooting out from the sun constantly. That's the solar wind. It's moving so fast that when it hits Earth, our entire planet's magnetic field has to work overtime to deflect it. And Earth is huge. We're talking about a planet with a molten iron core thousands of kilometers across, generating our protective magnetic bubble. But here's the thing that should blow your mind. Atlas is less than a kilometer wide. It's tiny compared to Earth. Yet it's creating deflection effects that match or even exceed what our entire planet does. How? Nobody knows. And that's what's keeping scientists up at night. Think about what this means. When solar storms hit Earth, those massive bursts of particles from the sun, our satellites get fried, power grids can go down, GPS systems fail. That's the solar wind overwhelming our planetary defenses. Now picture something the size of a large building doing a better job at deflecting that same force. It's like watching a person hold back a tsunami with their bare hands. And it gets weirder. When comets, which are way bigger than ATLAS, pass through the solar wind, they barely make a dent. Sure, the solar wind pushes their tails around, but the comet nucleus itself, it just takes the hit. The solar wind flows right over it, like it's not even there. But ATLAS, the solar wind, is bending around it like there's an invisible force field. And we're not talking small deflections here. We're talking about the solar wind starting to curve tens of thousands of kilometers before it even reaches Atlas. It's like the solar wind sees Atlas coming and decides to go around it way in advance. Scientists are running calculations and coming up with numbers that make no sense. The magnetic field strength needed to create what we're seeing would require technology that's theoretically impossible at that scale. We're talking about field strengths thousands of times more powerful than anything humans have ever created, generated by something you could park in a football stadium. Okay, so here's where things go from "that's really weird" to "what the hell are we actually looking at?" The deflection zone, the area where solar wind is being pushed around Atlas, extends 40,000 kilometers in every direction. Let me put that in perspective. That's 3 times the diameter of Earth. Atlas is creating a protective bubble around itself that could fit 3 Earths inside it, from an object that's less than a kilometer across. But wait, it gets crazier. This isn't just one simple bubble. Scientists are detecting layers, like an onion made of invisible force fields. The outer layer, about 30,000 kilometers out, slows down the solar wind particles by 15%. They're losing speed, losing energy, like they're hitting an invisible wall. Then there's a second layer closer in, around 15,000 kilometers from Atlas. And this one, it's doing the opposite. It's accelerating particles, adding energy to them, pushing them in specific directions around Atlas. It's like Atlas has a 2-stage defense system. Slow the threat down first, then redirect it away. Think about what that means. This isn't a passive magnetic field like Earth's, where solar wind just bounces off naturally. This is active manipulation. Atlas is doing something to these particles, grabbing them with invisible hands, slowing them down, speeding them up, steering them where it wants them to go. And here's the part that's making physicists question everything. The solar wind is getting hotter as it passes through these zones. Temperature increases by 40%. Where's that heat coming from? Heating plasma requires energy, lots of it. Atlas is pumping energy into the solar wind while simultaneously deflecting it. One scientist described it like this. It's like watching someone not just block a punch, but catch the fist, slow it down, redirect it, and set it on fire all at the same time. That's not defense, that's total control. What's even more mind-blowing is that this whole system is operating continuously. 24 hours a day, 7 days a week, Atlas is maintaining this massive deflection zone. The power requirements for that? We're talking about the output of a major city's power grid running non-stop from something the size of a building. And nobody can explain where that power is coming from. But here's where it goes from impossible to absolutely terrifying. The deflection zone changes, like actively changes in response to what's happening around it. When there's a solar storm, one of those massive eruptions from the sun that would normally fry satellites and cause problems on Earth, Atlas's deflection zone doesn't just sit there and take it, it gets stronger. The protective bubble expands, the particle deflection becomes more aggressive, and ATLAS essentially goes into defensive mode. Let that sink in. Atlas is monitoring the solar wind, it's detecting threats, and it's responding in real time by adjusting its defenses. That means there's either incredibly advanced artificial intelligence running these systems or something conscious is actively managing them. One researcher watching these changes happen described it like watching someone put up storm shutters when they see a hurricane coming, then opening them back up when it passes. That's not how physics works. That's how intelligent systems work. But it gets even stranger. Every few hours, the deflection zone pulses. It expands by about 15%, then contracts back to normal size, over and over again, like a heartbeat. What's that about? Is it some kind of system reset? A scanning pulse? A signal being sent through the solar wind itself? And here's the really creepy part. The deflection zone is asymmetric. It's stronger on the side facing the sun, the side where the solar wind is coming from, and weaker on the back side. That's optimization. That's deliberately allocating resources where they're most needed. That's what you'd do if you were designing a spacecraft shield and you wanted maximum protection with minimum power consumption. Scientists are also noticing that when Atlas makes those course corrections we've been tracking, the deflection zone reconfigures. It shifts, adjusts its shape, maintains optimal coverage based on the new direction of travel. It's integrated with the navigation system. This isn't just a defense mechanism someone turned on when they built Atlas. This is an active, intelligent system making decisions about how to protect itself moment by moment. So scientists are scrambling to explain how any of this is possible, and every theory they come up with has a massive problem that makes you wonder if we're even asking the right questions. Theory 1. Maybe ATLAS has some kind of super powerful magnetic field generator. Like technology so advanced, it can create magnetic fields thousands of times stronger than anything we can make, but somehow small enough to fit inside that 800-meter object. Problem: even if you could miniaturize the equipment that much, which we can't, where's the power coming from? We're talking about continuous output equivalent to a nuclear power plant. You can't hide that kind of energy generation. We'd see heat signatures, we'd detect radiation, but Atlas is just doing it. No visible power source at all. Theory 2, what if a TLAS is shooting out its own plasma, creating a cloud of charged particles around itself that pushes against the solar wind, like a plasma force field? Problem: the amount of material you'd need to constantly eject to maintain that kind of cloud? You'd run out fast. Really fast. Atlas would need to be carrying massive reserves of ejectable matter, and we'd see the material flowing out. We don't see any of that. Theory 3, and this is where things get wild. What if ATLAS is using electromagnetic field coils or something similar to actively grab individual particles and throw them in different directions, like real-time particle manipulation on a massive scale? Think about what that would require. You'd need to track millions of individual particles simultaneously, calculate optimal deflection paths for each one, generate precise electromagnetic fields to grab them and redirect them. All of this happening microsecond by microsecond across tens of thousands of kilometers. That's not just advanced technology. That's technology so far beyond what we can do that it might as well be magic. We're talking about computers processing more data in a second than all of human civilization's computers combined, while generating electromagnetic fields with precision we can't even measure. But here's the theory that's really making people nervous. What if ATLAS isn't using magnetic fields or plasma at all? What if it's bending space-time itself? Einstein showed us that massive objects curve space-time and particles follow those curves. But creating significant space-time curvature requires enormous mass, like planet-sized mass. Atlas doesn't have that, unless it has technology that can create artificial gravity fields, technology that can manipulate the fabric of reality without needing massive amounts of matter. If that's what we're looking at, that's not just advanced propulsion, that's control over fundamental forces. That's technology that could theoretically do anything: create artificial gravity, generate wormholes, maybe even manipulate time itself in localized regions. And the scary part? Some of the data actually fits that model better than the magnetic field explanations. Here's where your mind should really start racing. Whatever Atlas is using to push the solar wind around could be the same technology it uses to move through space. Think about it. If you can generate fields powerful enough to deflect high-speed plasma particles for protection, you can also use those same fields to push against those particles for propulsion. You'd essentially be sailing on the solar wind, but with technology so advanced you can steer perfectly and accelerate continuously without carrying any fuel. This concept is called a magnetic sail, and humans have theorized about it for decades. But what we're seeing with ATLAS, it's like comparing a child's toy sailboat to a nuclear-powered aircraft carrier. The scale and sophistication are incomprehensible. But it gets more interesting. What if the deflection zone we're seeing isn't just passive protection? What if Atlas is actively using it for propulsion right now? Every course correction we've documented, every velocity change, maybe those aren't coming from traditional engines. Maybe Atlas is adjusting its deflection field geometry to generate thrust. That would explain something that's been bothering scientists. ATLAS doesn't show any exhaust, any reaction mass, any visible propulsion system. No rocket plume, no material being ejected for thrust. It just changes velocity when it wants to. If it's using field manipulation for propulsion, you wouldn't see traditional rocket signatures. You'd just see an object steering itself through space using forces invisible to most detection methods. And here's the really crazy implication. If ATLAS can do this in our solar system where there's solar wind to push against, what was it using during the years or centuries it spent in the empty space between stars? The same field generation technology might work in multiple ways. Push against plasma particles when they're available, manipulate space-time directly when they're not. This suggests that advanced civilizations don't build separate systems for protection, propulsion, and power generation. They build unified field generators that serve all functions simultaneously through software control. Atlas isn't a spacecraft with a shield, engines, and reactor. Atlas is a spacecraft where the shield is the engine and the engine is the power system, all integrated into one impossible piece of technology. Okay, let's talk about the elephant in the room, power. Specifically, where the hell is ATLAS getting the energy to do all this? Conservative estimates suggest maintaining this deflection zone requires at least 50 to 100 megawatts of continuous power. That's a large city's worth of electricity running non-stop. During solar storms, when the deflection zone strengthens, we're looking at hundreds of megawatts from something less than a kilometer across. Solar panels? Not even close to enough. Even if Atlas's entire surface was covered in 100% efficient solar panels, which it's not, you couldn't generate that kind of power at Earth's distance from the Sun. And Atlas had to travel through interstellar space where there's basically no sunlight at all. Solar power doesn't cut it. Nuclear reactors? Maybe, but here's the problem. Nuclear reactors are heavy, they're bulky, they need shielding. Even our most advanced theoretical fission reactor designs can't achieve the power-to-weight ratio that would explain what we're seeing from ATLAS. So that leaves the really exotic possibilities. Matter-antimatter annihilation. When matter and antimatter particles collide, they convert 100% of their mass directly into pure energy. Einstein's E equals mc squared in action. A few kilograms of antimatter could power ATLAS's systems for months or years. It's the most energy-dense process we know of in physics. But here's the catch. Humans have created maybe a few nanograms of antimatter in total throughout all of history. Storing it without it immediately annihilating with regular matter is incredibly difficult. If Atlas uses antimatter power, that alone represents technology centuries beyond our capabilities. Or, and this is where things get really weird, what if ATLAS is using zero-point energy? There's a theoretical concept in quantum physics that even empty space isn't really empty. The vacuum of space is full of quantum fluctuations, virtual particles popping in and out of existence. If you could somehow extract energy from those fluctuations, you'd have effectively unlimited power with zero fuel requirements. It's purely theoretical for us. We don't know if it's even possible to extract useful energy from the quantum vacuum, but Atlas's complete lack of visible fuel storage or massive power generation systems suggests it might be using something exactly this exotic. Whatever the answer, one thing is clear. Atlas has solved energy generation problems that we're still struggling with conceptually. It's running systems that require city-scale power output from a compact, apparently unlimited energy source that doesn't show up on our sensors at all. That's technology so advanced it looks like it's breaking conservation of energy laws. Even though it probably isn't, we just don't understand the principles it's operating on. Here's what keeps me up at night. The deflection zone tells us things about ATLAS that go way beyond just, wow, cool technology. First, ATLAS is fully operational. This isn't some ancient derelict probe coasting through space on momentum. The systems are active, responsive, and functioning at what appears to be peak efficiency. Whatever mission Atlas is on, it's executing that mission right now with all systems green. Second, there's intelligence behind this, and that intelligence is paying attention. The adaptive responses to solar storms, the optimization of field geometry, the reconfiguration during maneuvers, all of that requires either extremely sophisticated artificial intelligence or conscious operators actively managing systems. Either way, something is making decisions about how Atlas operates moment by moment. Third, and this is the unsettling part, Atlas considers our solar system dangerous enough that it needs military-grade active defense systems running continuously. Think about that. Whatever built Atlas thought the solar system environment was sufficiently threatening that passive shielding wasn't enough. They needed active, adaptive, multi-layered protection. What's it protecting against? Natural radiation and particle impacts, obviously. But is that all? The way these systems are configured, the two-stage defense, the rapid strengthening during threats, the asymmetric optimization, it all looks like military defensive technology, the kind of thing you build when you're expecting more than just natural hazards. Is Atlas worried about our spacecraft getting too close? About human interference? Or is it concerned about threats we haven't even identified yet? And consider this, the amount of power Atlas dedicates to maintaining these defenses is enormous. That's energy that could theoretically be used for faster propulsion, more powerful communications, additional scientific instruments. The fact that running these defensive systems is considered worth the massive power expenditure suggests either that protection is absolutely critical to mission success, or that power is so abundant that running city-scale defense systems continuously isn't even a significant drain on resources. Some researchers are starting to wonder if the deflection zone is defensive rather than just protective. Like, maybe whoever built Atlas expects their spacecraft to face threats, either from primitive civilizations like humans who might try to interfere, or from other spacefaring powers we don't know about yet. Maybe the galaxy is more crowded and more dangerous than we realize, and serious interstellar travelers don't venture out without serious defensive capabilities. So here's where we are. Atlas is continuing its journey through our solar system, bending the solar wind around itself in ways that challenge everything we thought we knew about physics and engineering. And it's heading toward its closest approach to Earth in the coming weeks. Here's what's about to happen. As Atlas gets closer, we're going to get the best observations of this deflection zone we've ever had. Earth-based instruments will be able to measure subtle effects that are impossible to detect from greater distances. We'll track exactly how the solar wind changes before, during, and after encountering ATLAS's fields. But here's the part that has scientists both excited and nervous. Earth has its own magnetosphere, our planet's natural magnetic shield. When Atlas gets close enough, there's a possibility that Atlas's deflection zone and Earth's magnetosphere might interact. They might interfere with each other, or overlap, or nobody really knows what might happen. Could we see aurora effects from the interaction? Temporary disruptions to Earth's magnetic field? Something even weirder? We're about to find out. Several spacecraft are being redirected to pass near ATLAS's trajectory, hoping to fly through the deflection zone directly and measure field strengths from inside. But there's risk in that approach. If Atlas interprets approaching spacecraft as threats, those defensive systems that can manipulate solar wind particles might also be capable of doing very bad things to nearby objects. We're essentially planning to poke something that demonstrates the ability to control fundamental forces on a massive scale and hoping it doesn't poke back. But whatever happens, we're going to learn more in the next few weeks than we've learned in all the months since Atlas arrived. The deflection zone is giving us a window into technology that operates on principles we're only beginning to glimpse. Every measurement, every observation, every weird interaction is teaching us something about what's possible when you advance far enough beyond where humanity currently stands. The solar wind has flowed through our solar system unchanged for billions of years. Atlas is the first thing we've ever seen that can control it, shape it, use it. Whether that's the most impressive technology demonstration in human history or the most unsettling display of power from something we don't understand, we're about to find out up close. What do you think is really going on with ATLAS's deflection zone? Is this technology we should be studying and learning from, or power we should be frightened of? Drop your thoughts in the comments. And subscribe, because as Atlas closes in on Earth, the mystery is only going to deepen, and you won't want to miss what happens when two magnetic fields from different worlds finally meet. Or whatever is running. Atlas knows what they're doing with plasma physics. This isn't amateur hour. This is expert-level manipulation of one of the most difficult phenomena in space science. Third, Atlas treats the solar system like a hostile environment. Our spacecraft? They just cruise through, accepting whatever radiation hits them. Maybe they have some passive shielding, but nothing like this. Atlas is running continuous active defense like it expects serious threats. Either the technology inside is incredibly sensitive and needs this level of protection, or Atlas is planning to be here for a long time and wants to minimize accumulated radiation damage. But here's what really gets people nervous. The amount of power Atlas burns just on defense. That's energy that could go to engines, sensors, weapons, communication systems, anything. Yet Atlas considers this defensive bubble worth the massive energy expenditure. Either protection is absolutely critical to whatever mission it's on, or, and this is the scary thought, power is so abundant that running city-scale defensive systems continuously doesn't even make a dent in available reserves. And some researchers are starting to use a different word instead of protective. They're calling it defensive. Like, maybe these systems aren't just keeping out natural radiation. Maybe they're designed to stop things from getting too close, human spacecraft, missiles, whatever. Maybe Atlas came here expecting it might need to defend itself, and this is what serious interstellar defensive technology looks like. If that's true, it means whoever built Atlas either knows Earth has spacefaring capability and might try something stupid, or the galaxy is dangerous enough that you don't go anywhere without serious defenses. Either option is unsettling.